Welcome to EarthSky's Sun News of the Week. I'm Deborah Byrd, and coming up, we're going to have Dr. C. Alex Young, who is a heliophysicist at NASA Goddard Space Flight Center in Greenbelt, Maryland. He's going to be talking with us about the incredible week of X flares that we've had. We had a X7 on Tuesday and an X9 yesterday. So hang on for that. But first, we had some amazing news this morning, and David Dalian of EarthSky is going to come in and tell you about that. Hi, Dave.
Hi, Debbie. Good afternoon or good morning, depending on where you are, or good evening. Yeah, we had some excitement on the sun and some excitement back down here on Earth this morning with a launch of the United Launch Alliance Vulcan rocket, and it had an anomaly, a malfunction, call it what you will. Let's take a look. It's pretty exciting. This is some breathtaking stuff. Boom. What you're looking at right here, that's the nozzle off of this solid rocket booster. It's not supposed to do that. So we're looking into it.
That thing that's flying there is the actual nozzle?
Yes, ma'am. This thing, I hope you can see my cursor. That is the nozzle off of one of the solid rocket boosters of this morning's launch. So yeah, you can say things went a little sideways, but surprised me anyway, the payload made it to its designated orbit. So
amazing.
This may or may not play into their certification. I guess we're going to find out about that.
All right. So that was just this morning.
That was just this very morning. And so we do have some more pictures with Greg Diesel, and maybe we'll share those later on back on the website, earthsky.org. That's all I've got for you.
Thank you so much, Dave. We'll see you on Monday. You're going to be back with me talking about the two comets in the October sky, 12:15 Central or 17:15 UTC on Monday.
I'll see you then.
Okay, see you
Bye-bye.
then. Okay, so now we have Alex. Alex, are you back there?
I am here.
Hey, hi. Let's talk about the X flares. Hang on, let me share a picture here.
All right. So
okay.
Yeah.
The X9.
X9. So that's the second of the big flares we've had this week. There's an active region on the sun, AR 3842, which has been very dynamic. It's been growing, and basically last weekend we started to notice lots more flares were coming, M flares, and then it got more and more and more, and it was certainly on its way to something interesting. And sure enough, on Tuesday it just let off an X7, but that wasn't the first one. I mean, the last one, because we just 24 hours ago, or so, had this X9, and since 1996, this is the 15th largest X flare and the largest X flare or largest flare from the current solar cycle.
Okay, so now the X flares, that's the largest category of flare.
Correct.
Okay, and so this is the largest X flare of this solar cycle 25.
Correct.
And that's an 11-year cycle. So the largest flare in this past 11-year period.
Mm-hmm.
But 15th largest since when? 96?
It's 1996.
Wow.
And there have been many larger flares, but actually, and during that time period, we had the largest flares that were recorded in modern history, which came during the famous October-November Halloween storms of 2003.
Wow. That's a long time ago.
Yeah, it's been a while.
Yeah. So, wow. Exciting. And now let me go to the next slide because I want to show the X7 too, because it's very cool. This is some beautiful footage that you put together, Alex, of the X7 that happened on Tuesday. So that when the X7 occurred, the sunspot region that caused the flare was situated in such a way that it released some stuff, right? That was
That's right.
coming our way.
Yeah, so it released a blob of solar material that also has magnetic field. We call those coronal mass ejections, or CMEs. And given its location, it's a little off to the side. It wasn't directly pointed at us, but it was pointed enough our way that when that CME left the sun, one of the sides of it is expected to sweep past the Earth and give us some action here.
Yeah. And so when you say action, you mean auroras, right?
Right. So what happens is
Not scary action.
no,
fun
not scary action. Yeah, but the what happens is actually it does much more than aurora. But aurora is what we see from it. But basically, what happens is the Earth has a big magnetic field, like a bar magnet, like a compass magnet, and when it's hit by this coronal mass ejection, that magnetic field rings like a bell. And when that happens, it creates all kinds of electrical currents in the upper atmosphere. And one of the results of that is oxygen and nitrogen are excited in the upper atmosphere, and they give us all these amazing colors, the northern or southern lights.
And so did we see any last night from that event, from the Tuesday event?
We have, as of last night, we had not seen the CME yet. So this was actually a fairly small CME, a little bit slower. Yeah.
And it takes several days to get here.
It takes several days. And so the various space weather agencies, in particular NOAA, which is the official space weather agency for the US, and their sister agency, NASA, both do computer models, but NOAA is the official prediction. And NOAA had estimated that this would be arriving late, probably late today into early tomorrow. It could have certainly been earlier, and it could be later. And these are really difficult to pin down. The error on these estimates is about 7 hours, so 7 hours in one direction or the other. And so we expect that it's going to be here any moment. I haven't looked at the most recent data. It could, in fact, actually be here by now. But the exciting addition to that is that the X9 flare also has a CME associated with it. And by the time we had the X9, you can actually see the X9 in my background. The active region, the sunspot region, was much more faced directly towards us, close to what we call disk center of the sun. And the CME that it released is larger, a bit more energetic, and more directed towards us. And so that CME is expected to kind of get here later today, maybe early in tomorrow, probably later tomorrow, maybe into Sunday.
Oh, so it's a cannibal, right?
Well, it may be a cannibal. We don't know. So what a cannibal CME is when you have two CMEs, and so they're traveling, and the first one is a little bit slow, and the second one is much faster. Okay, and so the second one basically combines with the first one, eats the first one, and what that does is that just makes a larger, more complicated CME, and usually can increase the chances for aurora, increase the strength of the interaction with Earth, and increase the strength of the aurora, which typically what that means is the stronger the aurora, the farther south you see it from the North Pole, or the farther north you see it from the South Pole.
That's cool. So is there a prediction about how strong these storms will get and how long through the weekend they'll last?
The length is a little bit tricky. However, we do have predictions of the strength of the storm. Now, initially, when we first had the prediction from associated with the X7, the prediction was originally for what's called a G2. So storms, they're geomagnetic storms. So it's a storm in the magnetic field of the Earth. So geo meaning Earth. So and we have a scale that goes G1 to 5. And they're roughly 10 times each. So like a G2 is about 10 times stronger than a G1. And so originally we expected it to be probably a G2, which we call that a moderate storm. And these levels are what NOAA uses. And I think most of the world follows that standard. However, now that we have the additional CME and some additional models, we're looking at possibly a G3 storm, which we call a strong storm. But as we have seen, even not too far in the past, sometimes we can be surprised. So what can happen? Sometimes nothing happens, and we basically get a dud. But sometimes the storm can be even stronger. Now, maybe the fact that we have this combination may make it stronger. It's very challenging to figure that out because it's based on a lot of the complicated structure inside that big blob, and it's very difficult to measure that. You basically have to have a spacecraft right in the right place for that to pass by and get information. And space is big, and we don't have spacecraft everywhere. So, it's
Right.
a challenge.
Right. So that the really big severe, the G5 severe storm that we had in May is not in the offing for this weekend, probably.
Probably, yeah.
But there's a possibility.
It's certainly possible, more than likely not. There was a lot more activity. Now, I will also say that there is additional flare activity. So we don't just have X flares. The flares that are slightly smaller are called M flares or moderate flares. And those also can have CMEs associated with them. And this sunspot region has produced some M flares that have some CMEs. Currently, it doesn't appear that combination is going to kick things up a notch, but it could happen. Now, the one you mentioned, the May 10 and 11 storm, there were several flares, both M and X, that combined, and the prediction was originally for a G3, then a G4. So G3 is strong, G4 is severe, but then we were surprised that it became a G5, which is extreme. Those are the biggest storms. Yeah.
Right.
And that was an event that was potentially a once in every 500-year event. Aurora was seen very close to the equator, which just does not happen generally.
So chances are we won't get that this weekend, but people at northerly latitudes, a good shot of seeing a good display.
Yeah, it's a good time to maybe take a trip to Fairbanks, Alaska, or hop on a plane and go to Lapland and Finland or something.
Oh, if only we could. That would be
so
much fun. Okay, let's move on because we've got more stuff to talk about here. So this is something else that happened this week that was very exciting. Can you tell us what's going on with this?
Yeah, so what you're seeing is a little graphic showing an animation of Parker Solar Probe. So Parker Solar Probe, launched in August of 2018, is the first probe that we have sent into the atmosphere of the sun. And this is the part of the atmosphere that where flares and CMEs occur. It's also the part of the atmosphere that you can see during a total solar eclipse. It's very important. It's very difficult to study. And this is something people have been trying and planning for more than 60 years. So this is it's an amazing marvel. The science it's produced is fantastic. And the engineering to have a spacecraft into that harsh environment is just amazing. And so each time it orbits the sun, when it gets to its closest point in its orbit near the sun, We call that perihelion. So that's the closest point. And this is the 21st perihelion.
Yes.
Oh, sorry. Is it 20? Yeah, 21st perihelion.
It is the 21st.
Yeah.
It happened on Monday.
It happened on Monday, right. And so the information that you see up there is at the time you see the approximate speed and the approximate distance from the surface of the sun, and even the temperature that the spacecraft is experiencing, all of which are incredibly high, incredibly, faster. This is the fastest object that humankind has ever created. Yeah, it's just phenomenal.
So it's moving at almost 400,000 miles per hour.
Almost 400,000 miles an hour. And so what's going to happen is, as it makes these loops around, it every so often makes a pass by Venus, the planet Venus. And it uses the gravity of Venus to give it a little bit of a boost, so that the next time it gets to the sun, it's a little bit closer.
And this image is from the 4th Venus flyby of Parker Solar Probe, which happened in 2021. But Parker Solar Probe is going past Venus again on November 6th.
Correct. And that's the 7th and final one. And that means that after that, it will then eventually reach its closest approach. And the closest approach, or the closest perihelion, is scheduled for December 24th. And when it reaches that point, it will be traveling close to 500,000 miles per hour.
Wow. Amazing. And it's going to get that close several times, I think I read.
That's right. So once it passes by Venus, unless it passes by Venus again, every time it orbits, it basically makes the same distance. And so that's the last Venus flyby. So it will, they're scheduled in the normal schedule of 26 flybys. The 24th flyby is the closest approach. And so it will make a couple of more. However, the spacecraft, as long as it continues to operate, which it should, because these things are, engineered, they're incredibly robust engineering. So it should continue to make trips around the sun each time, gathering more data, potentially running into solar storms at the origin, it's happened before. And so it's going to continue to just do all kinds of amazing science. And almost always when you do this kind of science, something surprises you, which is what's one of the things that's so exciting about science.
It really is. And I love the way NASA talks about this spacecraft, because they sometimes say that Parker Solar Probe touches the sun. It's the spacecraft that touches the sun.
That's right, because it's flying through the outer part of the atmosphere, which is part of the sun, and it is touching that. It is flying through that part of the atmosphere we call the corona.
That's awesome. Okay, so that's Parker Solar Probe. And its perihelion, its 21st perihelion, was this past Monday. And it'll be going past Venus on November 6th and closest point to the sun on Christmas Eve.
That's right.
So exciting. So we have just one more thing to talk about, and that is the planet Mercury. So I just threw this one in for fun. It's fun to see these, especially for those of us who've been doing astronomy for a long, long time. And we've been talking about, Mercury passing behind the sun from Earth, or maybe not passing directly behind, as in this case, but getting as close as it can to passing behind the sun from Earth. And astronomers call that a superior conjunction. And Mercury was at superior conjunction on September 30th. And one of the fleet of sun-observing spacecraft caught it in that position.
Yeah. This is a spacecraft that's been around since 1995, and it's called SOHO. And one of the most important instruments currently on SOHO are these coronagraphs, which are basically like an artificial eclipse. So the bright sun is blocked out, and that allows us to see these huge eruptions as they leave the sun. But one of the added things that's really cool about it is these cameras are incredibly sensitive, and planets are very bright, especially when they're very close to the sun, because they're just reflecting light off of them. So we see planets. We also see comets as they get close to the sun. And in the background, we can see certain sets of stars, certain constellations. And so this is sort of an amazing instrument that's been doing such amazing science and gathering this cool data for so long.
And it's mind-blowing, really, what it can do. It's just amazing. So speaking of comets coming near the sun, we are going to be back here in the studio. I'll put us back this way. On Monday, we're going to be talking about and Alex, thank you very much for joining us today. We really appreciate all your amazing info. I've been speaking with Dr. C. Alex Young. He's a heliophysicist at NASA Goddard Space Flight Center in Greenbelt, Maryland. Come back on Monday, and Dave Adalian, who was here earlier, and I are going to be talking about the 2 comets, not one, but 2 comets that may be visible in Earth's sky in October.
Fantastic.
I know, it is amazing. And one of them is a sun grazer comet that would have been caught. I don't know if it was caught on one of those instruments. Oh, it hasn't had it. Its perihelion hasn't happened yet.
Well,
so that's...
And I'm excited because I'm going to Chile at the end of October, and I might get to see one of them in the Chilean desert.
Oh, that's so cool. And you'll be in the Southern Hemisphere. And for some weird reason, everything is always better from the Southern Hemisphere. I've actually heard the reason why that's true. And there's several reasons, but I'll have to hear that again. I think it was Guy Ottewell. We work with him often. I don't know how many people listening know Guy Ottewell, but he's a UK astronomer, and he knows a lot about how Earth is positioned in space and how things are happening 3-dimensionally and that sort of thing. So yeah, I think he's the one who said it's better from the Southern Hemisphere for real reasons. It doesn't just seem like that, but it really is true. So Alex, thank you for being here today. Come back and join us on Monday at 12:15 p.m. Central or 17:15 UTC. And we will be talking about the 2 comets, bright comets that may be visible in Earth's sky in the month of October. We hope we see you then.